Hello, ninth graders. Welcome to the last online lesson of Chapter Circle, wherein you're going to look into a few problems from exercise 10.5. And at the end of this online class, you will also learn the important theorems that you have to do from this chapter and certain theorems where only statements have to be learned. Please have a look. This is an important point. In a circle, if there are two chords which are congruent, here chord AB and chord CD are equal to each other, that means the length of these two chords are the same. So in a situation like this, you will notice that the corresponding arc AMB will be congruent to arc CND, and vice versa. If the arcs are congruent, then the corresponding chords will be equal. You have to remember this statement. Now this is the second question of exercise 10.5. It's quite an important question. They have mentioned that there is a chord on the circle. So you have to draw a circle and I have taken chord AB. The length of this chord is equal to the radius of the circle. So let us assume that AB, which is the chord, is having length as R representing here radius of the circle. OA is already the radius of the circle and OB is also the radius of the circle. These three sides now become congruent because each is represented by R. So we get triangle AOB, which is an equilateral triangle. And they have asked here to find out the measure of angle in the major arc, which is angle ADB, and the measure of the angle in the minor arc, which is angle ACB. So construction, join OA and OB, you get an equilateral triangle, and each and every angle of the equilateral triangle is 60 degree. So measure angle AOB is 60 degree. Now you need to find out what is the measure of the angle in the major arc. So that is angle ADB. And you have learned this in the previous online class, that the measure of the angle at the center is double the measure of the angle subtended by the same arc at any other point on the circle. So this central angle measure AOB, which is 60 degree, is double angle ADB. So the measure of angle ADB will be 30 degree. Now that you have got ADB as 30, which is an angle in the major arc, how would you find the measure of the angle in the minor arc? So I have taken this angle ACB. If you look at this quadrilateral ADBC, it is a cyclic quadrilateral. In this cyclic quadrilateral, the sum of the opposite angles are supplementary. So 30 degree plus what will give you 180 degree? So measure angle ACB equal to 150. So take chord AB, you get an equilateral triangle AOB. After that you get this angle as 60. Once you know this angle, central angle is 60, this becomes 30. And the opposite angle will be 150 because it is opposite angle of a cyclic quadrilateral. Now let us look into another question from the same exercise. Question number 9. This question is also very important. You have to prove that angle ACP and angle QCD, these two angles are equal. So take the larger circle. In this larger circle, look at arc AP. If I join these 2 points A and P, I get chord AP. Chord of a circle divides a circle into segments. So this becomes the major segment. In the bigger circle, this is the major segment. So look at the angles in the major segment. Angle ACP will be equal to angle ABP. It's shown here in black. These two angles will be equal because they are angles in the same segment. The clue here is you start with what is given. So we start with angle ACP and look at an angle which is congruent to ACP. So it will be angle ABP. Similarly, look at the smaller circle. In the smaller circle, look at this arc DQ, and if I join it, I get chord QD. Look for angles in the major segment. Now, like I said, you can start with what is given, QCD. So angle QCD is equal to angle QBD. These two angles shown in red. They are equal because they are angles in the same segment of the circle. Now compare statement 1 and 2. You will notice that the right side of these two statements are equal. And why are they equal? Because they are vertically opposite angles. See these two, the one in black and red, they are vertically opposite. So if the right side of the equation is equal, what happens to the left side? The left side becomes equal. So you get ACP equal to angle QCD. So this is also an important question from exercise 10.5. Let us look into one more question from this exercise. Question number 11 from 10.5. ABC and ADC are two right angle triangles with common hypotenuse AC. And you have to prove these two angles are congruent. So I have taken angle ABC, which is a right angle, and angle ADC, a right angle. Why is it that a circle is drawn? Because you have learned that angle in a semicircle is a right angle. So obviously if angle B and angle D, both of them are 90°, it has to lie in the semicircular region. So that is why a circle is drawn. AC is the diameter of the circle and angle in a semicircle is a right angle. Look at chord CD. You have angles in the same segment of the circle equal. So angle which is subtended by this arc CD or subtended by this chord CD is angle CBD, here the one in black, which is congruent to angle CAD, here in black. These two angles, they become congruent because they are angles subtended by this chord CD and they lie in the major segment. So angles in the same segment are equal. You could also draw the diagram like this. This is another way to draw the figure where angle B is above and another right angle D is below. So B equal to D, which is equal to 90. And why a circle? Because it is 90, you will have a semicircular region. Angle in a semicircle is a right angle. Now these two angles which is shown in green, that is angle CBD, will be equal to angle CAD because they are angles in the same segment of the circle. And which is the segment of the circle? This region. And how are they formed? They are formed by this chord CD. So this CD is dividing the circle into this region is the minor segment and this is the major segment. So they are equal because they lie in the same segment. Now here we have used the property angles in the same segment of a circle are equal, and another property angle in the semicircular region is always a right angle. Now let us have a look into the summary, what all we have learned in this chapter. Now these are some of the theorems that we have learned and some important points are jotted down. The definition of the circle, we have done this in the first online class. And then a circle, one and only one circle can pass through three non-collinear points. This is a theorem, equal chords of a circle subtend equal angles at the center. Fourth point is also a theorem which you have to learn to prove. Then these are some important points that you need to remember. You don't need to learn how to prove them. Angles in the same segment of a circle are equal. We just saw that now. An angle in a semicircle is a right angle. This is also an important property of a cyclic quadrilateral, that if the quadrilateral is cyclic, then both the pairs of opposite angles will be 180 degree. And if any one pair of opposite angle is supplementary, then the quadrilateral becomes a cyclic quadrilateral. In the next slide, you will see important theorems from this chapter. And those theorems, I want you to learn to prove it because we have done it in the video lesson. Okay. These are the important theorems from this chapter. 10.1, equal chords of a circle subtend equal angles at the center. You have to learn to prove it. It is done in the video lesson. Also, the converse of this theorem is theorem 10.2. Then 10.3, again a very important theorem. The perpendicular from the center of the circle to the chord bisects the chord. And its converse. Its converse is theorem 10.4. Then theorem 10.8, the angle subtended by an arc at the center is double the angle subtended by the same arc at any other point on the remaining part of the circle. Theorem 10.11, wherein you have to prove the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Now in this chapter there are many theorems, but these are the theorems that I want you to learn to prove. You could get a question like this: prove the perpendicular from the center of a circle to a chord bisects a chord. So students, please make a note of this. 1, 2, 3, 4, 5, 6. These 6 theorems, you have to learn to prove them. Okay. In the next slide, you will look into few more theorems, but those theorems you have to only remember the statement. Please have a look. So I hope you have jotted this down. This is how it is mentioned in the textbook also, theorem 10.1, 10.2, 10.3. Okay. The theorems given below, remember only the statements. Like angles in the same segment of a circle are equal. You're using this sentence when you're solving questions from 10.5. Similarly, we use a statement, sum of opposite angles of a cyclic quadrilateral is supplementary. Okay, so remember these theorems. I want you to learn only the statements of these theorems. Thank you.